CSI and Physics, Crime Scene Investigation and Physics 2034, Quiz 2034. A car is found in the lake at the position shown. This is the position that is shown. A car is found in the lake at the position shown. What is the approximate speed of the car at P before it went flying into the water? So we have to think of this as water. Distance from P to Q is 19.6 meters. So along the vertical, it is 19.6 meters. Distance from Q to R is 50 meters. So along the horizontal, it is 50 meters. Assume constant acceleration due to gravity, negative 9.8 meters per second. Define positive x as to the right and positive y as vertically up. So is it A, 25 meters per second, or is it B, 35 meters per second, or is it C, 40 meters per second? So we have to resolve this into vertical and horizontal. Let's assume that we have our origin here. So that's our origin. So with respect to the origin, where is point Q? So what is the initial position? It is 0. At point P, it is 0. So we have 0 at point P. What is Y final? What is the vertical position of point R? It is 19.6 meters below. So along the vertical, it is 19.6 meters below. It is 19.6 meters below. So it is negative 19.6 meters. So what is delta Y? Change in Y for the car as it moves from point P to point R is Y final minus Y initial. Y final is negative 19.6. Y initial is 0, so you get negative 19.6. So since the acceleration is a constant, we can use delta y is equal to v0 yt plus 1/2 acceleration along y times time squared. Delta y is negative 19.6. The car shoots off horizontally at the start at point P. So what is the initial vertical velocity? It is 0. And what is 0 times anything? 0 times t, 0 times t is 0. So this whole thing is equal to 0. And we have 1/2 acceleration due to gravity, acceleration along the vertical. Y, vertical, acceleration along the vertical is negative 9.8 times t squared. So you get time is equal to 2 seconds. When you solve for it, we get time is equal to 2 seconds. Along the horizontal, what do you see? Where is point R? Point R is 50 meters out. So it is 50 minus 0. So what is delta x? It is 50 minus 0, and that is 50 meters. And you know that delta x is equal to v0x, initial velocity along the horizontal times time plus 1/2 acceleration along the horizontal times time squared. Acceleration along the horizontal is 0, so this whole thing is equal to 0. There is no pull or push along the horizontal. So this whole thing is equal to 0. So what are we left with? 50 is equal to v0, we don't know what is the horizontal speed at point P, times time. Time is 2 seconds. So what do you get for the launch? 50 divided by 2, and that is 25 meters per second. The horizontal velocity is unaffected by acceleration due to gravity along the vertical. So for that reason, the speed of the car is 25 meters per second. So that's what I did here. Solve vertical and horizontal separate. Solve vertical and horizontal separate. Along the vertical, what do we know? Initial vertical position, 0 meters. Final vertical position, do not forget our figure here. So this is at the point P, and this is point R, and this is point Q. So as you fall from P to R, what is the change in the vertical position? It is negative 19.6. Negative 19.6. Initial vertical position, 0. Final vertical position, it is 19.6 meters below 0. So it is negative 19.6. So what is change in y? Y final minus y initial, negative 19.6. Negative means the final vertical position is below the initial starting point. That's all. Initial vertical velocity is 0. If you had vertical velocity, the car would have gone like that or something like that. Okay. So initial vertical velocity is 0. It does not have an initial vertical velocity. There is no vertical velocity at the start. After the launch, vertical velocity picks up in speed. As it falls, what happens? The vertical velocity picks up in speed. Let t be the time it takes to reach point R. Acceleration along the vertical is negative 9.8 meters per second. So we substitute all those numbers that we know. Delta y, we use delta y is equal to v0 yt plus 1/2 at squared. Please don't forget, we are putting everything with respect to the vertical. So change in y with respect to the vertical, initial velocity with respect to the vertical, acceleration with respect to the vertical. So what is change in y? Negative 19.6. Initial velocity along the vertical, 0. We don't know what time is. We know the acceleration along the vertical, and that is negative 9.8. So change in y is equal to v0 yt plus 1/2 at squared. So we substitute for change in y, negative 19.6. Initial velocity is 0, so this whole thing goes to 0. So what are we left with? 1/2 acceleration along the vertical, negative 9.8 t squared. So you get negative 19.6 equals negative 1/2 9.8 t squared. We get t squared is equal to 4. So what is t? Plus or minus square root of 4. Because square of t equals 4. So t has both positive and negative values for the solution. So does that mean that we have 2 times? No. We assume that the negative time does not exist. So we ignore negative solutions. We ignore negative solutions for time. So what is the time? It is positive 2 seconds. So we have positive 2 seconds for the time. As it falls from P to R, what is the time it takes to go from P to R? It is 2 seconds. And in that 2 seconds, what does it do along the horizontal? Along the horizontal, it moves 50 meters. And so we now do the displacement equation for the horizontal. Initial velocity times time plus 1/2 acceleration along the horizontal. This is all along the horizontal, okay? Horizontal acceleration is 0. There is no pull or push along the horizontal. That goes to 0. So what are we left with? Delta x is equal to 50. We know that. We don't know the initial velocity along the horizontal, but we do know the time. So acceleration along the horizontal does not exist. Horizontal starting velocity is unaffected by gravitational pull along the vertical. So acceleration is 0. So we substitute, and what do we get? We get 50 is equal to, this whole thing is equal to 0. 50 is equal to v initial times time along the horizontal. 50 is equal to velocity along the horizontal times 2, because time is equal to 2. So you get v initial along the horizontal is 50 divided by 2, which is 25 meters per second. 25 meters per second. So what is the speed of the car as it flies off at point P? It has to be 25 meters per second. And this is George Mathew signing off for both myself and my dad. Good luck.